We are given standard reduction potentials for lead, nickel, cadmium, and iron. The solution contains 0.001 molar X2 plus and 0.1 molar Y2 plus. Since X dissolves, X is getting oxidized. Let us solve step by step. If metal X dissolves, X is the anode and gets oxidized. Therefore, the Y electrode must have the higher reduction potential. So we need EY minus EX to be positive. For both electrodes, the number of electrons is 2. Subtracting the two Nernst equations gives a standard potential difference plus a concentration correction. The concentration ratio is 100. At 298 Kelvin, the concentration term comes out to about 0.059 volt. So we just add this to Y standard potential minus X standard potential. For option A, cadmium is X and nickel is Y, giving a positive value, so cadmium dissolves. For option B, cadmium is X and iron is Y, and the value is still slightly positive, so cadmium also dissolves. For option C, nickel is X and lead is Y, so the value is positive and nickel dissolves. For option D, nickel is X and iron is Y, but the value is negative, so nickel will not dissolve. Therefore, the correct combinations are A, B, and C. For more such clear step-by-step solutions, keep learning with Acharya.